Hi, welcome to the Dr. Lam Show. We have Ari Whitten here today, who is a functional medicine expert and founder of the Energy Blueprint. He is writing a book, and it's actually coming out very soon. It's called Eat for Energy: How to Beat Fatigue, Supercharge Your Mitochondria, and Unlock All Day Energy. Most of my listeners and people listening to this podcast deal with fatigue. That's kind of what this podcast is all about. So you're going to love as we talk with Ari about his unique scientific framework to reclaim energy, brain power, and well-being using nutrition, sleep, and daily habits. So very happy to have you here, Ari.
Yeah, thank you so much for having me.
So, I always like to ask, how did you get to where you're at? What's your journey in doing in becoming so passionate about this?
I'll give you the very short version, so we can spend as much time as possible talking about the science and practical strategies to improve energy levels. The short version is health science has been my passion and obsession since a very young age, since I was about 12 or 13 years old. And I'm now 38. And really, it's been my passion for pretty much my entire life at this point. Early on, it was more fitness, body composition focused. I was very into bodybuilding when I was younger. My older brother was a personal trainer and bodybuilder, so I kind of got funneled into things from that side of things. I was also an athlete. And so early on, that was more my world: exercise physiology, nutrition, fitness, body composition. And then in my mid-20s, I got mononucleosis from Epstein-Barr virus, and I was incapacitated from that for several months and ultimately close to a year, dealing with pretty severe chronic fatigue. And that really rocked my world. Always being fit and healthy and athletic, having lots of energy, it completely changed my life to not have much energy anymore. And that was the catalyst for me for becoming very interested in energy levels. And as I dug deeper into that topic, I started to discover, and I'm happy to talk about specifics of what I'm about to say if you'd like to delve into that. But I discovered that really within conventional medicine and within the natural health, wellness, functional medicine space, people did not really understand what was causing fatigue and how to fix it. What are the real factors that are regulating human energy levels? So that was really the catalyst for me to devote my life, which I've been doing for the past decade, to understanding this and really building out our understanding of the science of human energy regulation and optimization.
Yeah, so energy in the basic sense, usually we think of the mitochondria, right? So if you can go a little into what is the mitochondria, what do they do, how is it so important to the energy production?
Yeah, well, first of all, I think our understanding of things being mitochondria centric is actually a new thing. So 10 years ago, when I was diagnosed with chronic fatigue syndrome, and I was dealing with that, and I was seeing all kinds of practitioners, no one was talking to me about mitochondria. Everybody was, conventional medical doctors really have nothing to offer people with chronic fatigue. They've got, stimulants and antidepressants and not much else. They don't have a coherent understanding of what's causing it. Within the alternative natural health functional medicine space, everybody was talking to me about adrenal fatigue. So I was diagnosed with adrenal fatigue, put on adrenal supplements. Everybody was focused on that. The big thing to understand about mitochondria is, if we think back to our high school and college biology classes, people were taught that mitochondria were sort of like these mindless energy generators that just sort of take in the food we eat, mainly carbs and fats, and they use those carbs and fats to run them through these processes in this electron transport chain. They use these carbs and fats to produce cellular energy in the form of ATP. And, that's how we learn about them. They're the powerhouses of the cell, quote unquote, and they produce energy. And that's like sort of this paradigm of mitochondria as mindless energy generators. And while all of that's true, that they are energy generators, and in fact, they are responsible for virtually all of the energy production by virtually all of the trillions of cells in our body. The story that they're just energy generators is really incomplete. In the last 5 or 10 years, there's been a revolution in our understanding of mitochondria, what they are, what they do. And it turns out that they have an entire second role beyond energy production that is really just discovered by science. You know, we've known about mitochondria for 100+ years. And, you know, you can look at them under a microscope and study them, and, you know, the bioenergetics of them, how they produce energy, all of that's been known for a very long time. But what hasn't been known is that they have this other role. And that role is in cellular defense. So it turns out that mitochondria are not just mindless energy generators. They are exquisitely sensitive environmental sensors. They are basically like the canaries in the coal mine of our body. And their job is to constantly be taking samples of what's going on inside the cell, what's going on inside the body, to ask one question in particular: are we under attack? Is there some kind of stress or danger present that is putting the body in threat? And this is the key to understand. To the degree that they are picking up on threats, they are turning down the dial on energy production. So if you think of it like this, mitochondria have 2 basic roles in the body: energy production and cell defense. And those 2 roles are mutually exclusive. So mitochondria are not just mindless energy generators, they are energy regulators, meaning they are actually the thing that is deciding whether or not to produce energy and how much energy they should be producing. In other words, whether they should be more in energy mode or cell defense mode. And to the degree that they are picking up on dangers or various kinds of stressors in the body, they are turning down energy production and shifting resources towards cell defense. And your energy levels, you as a person, as a collection of trillions of cells, each with hundreds to thousands of mitochondria in them that are responsible for producing virtually all the energy that powers those cells, you, on the macro level, are feeling the subjective state of either having lots of energy or very little energy, chronic fatigue, for example. And that, the energy that you feel, is a function of the degree to which your mitochondria are either in energy mode or defense mode.
Yeah, so it's a lot of information, and it's new science, like you said, which is really exciting. Where we always think that, yes, my energy packets come from the mitochondria, but now you're talking about cell defense. Can you explain a little? Is it meaning, does the mitochondria go around looking for these toxins, or how? What are they usually defending against, if you can say, in our general world today?
Yeah. So mitochondria are not immune cells. They're not part of our, you know, the actual white blood cells that are going around and munching up pathogens or something like that. Mm-hmm. They are what Robert Naviaux, who is an MD PhD who runs a lab for mitochondrial medicine at the University of California, San Diego, who is really kind of the scientist who has figured out this role of mitochondria. He calls them the central hub of the wheel of metabolism. So in other words, and there's lots of papers written on the role of mitochondria in innate immune function. So it's not that they're going around the body and, you know, killing off pathogens or something like that. They're stationary inside of cells, but they're detecting the presence of stressors that are present in the body. And those stressors could be anything from pathogens to environmental toxicants, to sleep deprivation, to psychological stress, to poor sleep and circadian rhythm disruption, to poor nutrition, and really any type of stressor you can imagine. And the mitochondria can sense the presence of those kinds of stressors. And the reason that it can sense such a diverse array of stressors is primarily because pretty much every type of stressor imaginable can be reduced down in terms of the biochemical level to a few different mechanisms: oxidative stress, increased inflammation or inflammatory cytokines, and cellular damage. Mitochondria pick up on those signals of oxidative stress, inflammation, and cellular damage. And in response to those signals, they then send out their own signaling cascade, something called retrograde signaling, where they are sending signals to the nucleus of the cell as far as what genes to express and what genes to turn down, to turn off. Okay, so mitochondria are regulating all kinds of other metabolic responses, including immune responses. So in response to a pathogen, for example, let's say you've got an infection, mitochondria are sensing that. Now they've turned down the dial on energy production. Well, if that sounds obscure to you, think of the last time you had a cold or a flu or COVID. What was one of the main symptoms of it? It was fatigue, right? Well, that's what's happening. So mitochondria are sensing the presence of that pathogen. They're turning down energy production, shifting resources towards cell defense by signaling for the immune system to be active, for inflammatory cytokines to go up, and so on. They're sealing off cells so that cells are less permeable and the pathogens don't have as easy of access. So they're shutting down somewhat the communication between cells. And they're essentially going to war, including things like if a cell is infected with a virus, let's say, the mitochondria detect the presence of that and they start producing huge amounts of reactive oxygen species or free radicals to destroy, to be toxic to the presence of the pathogen inside of that cell. Okay, so that's what it means to turn down energy production and shift resources towards cell defense. But in addition to what's going on in each cell, they're also sending signals out throughout the body that are coordinating widespread metabolic responses to that stressor.
So they're kind of like a general that is basically telling their armies what to do. Is that what you're saying? Based on the signals that come in, right? So sounds like a very important role for the mitochondria to play. And so what is a way that you can whether test for it, or is it just, hey, if you're fatigued, you're going to have mitochondrial dysfunction, I guess?
It's a good question without a great answer. There are a few tests that exist for testing mitochondrial health. I would say they're all pretty imperfect. There are indirect tests like organic acid tests that can tell you some things. There's a mito swab test, which you can swab the inside of your mouth and you can get some insight into mitochondrial function. There's an ATP profile test that was created by some chronic fatigue researchers in the UK. The truth is we probably won't have great testing for this until the use of metabolomics tests become more widespread, where you can do blood panels that track 500-600 different metabolites, because we know from metabolomic studies on people with chronic fatigue that there is a signature for this, that there is a particular kind of signature as far as what these hundreds of different biomarkers look like in people with chronic fatigue syndrome, for example. We also know that this is true in the case of the gut microbiome. We know that people with chronic fatigue syndrome have a kind of a gut microbiome signature that is predictive of chronic fatigue. So we know that they have lower rates of bifidobacteria, for example. We know that they have lower rates of or lower amounts of short chain fatty acid producing bacteria, things like butyrate producing bacteria. And we know that they have higher amounts of LPS endotoxin containing bacteria and signatures of gut permeability. So there's actually a study that's been done where they used a computer program to analyze these different markers of the gut microbiome. And they found that this computer program, just using gut microbiome data and nothing else, is 90% predictive, can predict with 90% accuracy whether someone is healthy or whether they have chronic fatigue syndrome, just by looking at these biomarkers related to the gut microbiome. So yeah, there are definitely things going on there, but I wouldn't say that there's one specific test that is really a great test for fatigue or chronic fatigue specifically, or even for mitochondrial health in particular. Keep in mind also, when it comes to mitochondria, part of what I'm talking about isn't necessarily even saying that the mitochondria themselves are dysfunctional. That is going on, and there is plenty of evidence to support that. But what I'm saying is actually more that they're shutting down, they're turning down the dial on energy production and shifting to defense mode. And that is, well, it's overlapping, but it's somewhat distinct from saying, hey, the mitochondria are totally dysfunctional, and that's the reason for your fatigue. It's more that due to the presence of environmental or lifestyle stressors, the mitochondria are shifting out of energy mode towards defense mode. And that's something we don't really have a test for.
Okay. So you talked now about these stressors that are turning the mitochondria to cellular defense. So how do we help our patients, or how do we help our readers of your book to be able to go through and see how we can fix this dysfunctional mitochondria?
Yeah. So there's many different lifestyle factors that play into this. And this discussion, could be very broad. So we could talk about environmental toxicants. We could talk about gut health. We can talk about hormetic stress, which is a big one. And that's how transient metabolic stressors work to support and build your mitochondria by challenging them. We could talk about circadian rhythm and sleep. We could talk about light deficiencies and toxicities and all the different wavelengths of light that are bioactive. I've also written a book, pretty much the book on red and near infrared light therapy. That's another thing that plays into this. But the new book that's coming out really focuses heavily on nutrition specifically. So what are the nutritional factors that are sending our mitochondria into defense mode and causing fatigue? And there are 5 main ones. So circadian rhythm is one, and obviously circadian rhythm has a light component to it as well, but it also has a strong nutritional component. Body composition, blood sugar levels, both hyper and hypoglycemia, gut health, and brain health. And so based on those different factors, those sort of 5 key factors that are going on in our nutrition, what people are doing wrong there, those are factors that are contributing to fatigue. So I'm happy to dive into any one of those that you want to jump into and talk some specifics.
Yeah, I think all those 5 that you talked about are very important, but I think we know a lot, and we discuss with our patients a lot already about the gut, and then environmental toxins too. So maybe you can dive. I'm very interested in this light that you're talking about. So maybe the circadian rhythm and the nutrition of that to
Sure.
start off.
Yeah. Yeah. So first of all, it's important to understand that 1/3 of adults sleep less than 6 hours a night, and another 1/3 have difficulty falling asleep or staying asleep. So we know that circadian rhythm and sleep issues are widespread, are really epidemic, and they're a massive factor in your energy levels. When you have poor sleep, in either inadequate amounts of sleep, or you're not sleeping well, you're not sleeping deeply enough, or what's called your sleep efficiency is not high enough, that the other aspect of that is that your energy is not going to be very good. Sleep and energy are really 2 sides of the same coin, and they are connected by the circadian rhythm. Now, we have this circadian rhythm, which is essentially a 24-hour biological clock built into our brain. And that is the central clock. Okay, we also have peripheral clocks. It's been discovered in recent years we have peripheral clocks in basically every tissue throughout our body, from our eyes to our skin, to our liver, to our pancreas, to our intestines, to every different part of our body has its own clocks. Now, the central clock in the brain, the central circadian rhythm, in a part of the brain called the suprachiasmatic nucleus. This clock, together with the peripheral clocks, they regulate all kinds of processes in our body. They either regulate or heavily influence many different processes in our body, from, of course, our sleep and wake cycle, to our energy levels, to our alertness and cognitive function, to our mood, to many different hormones that are heavily impacted by circadian rhythms, including things like cortisol and testosterone and growth hormone and insulin levels. We know that they're also influencing many different neurotransmitters that impact on energy and mood and drive. The impact on dopamine and serotonin and GABA. So when your circadian rhythm is not optimized, you have widespread systemic consequences, basically in every system of your body. And of course, heavily impacting both sleep quality and energy levels. Now, we know, for example, that in chronic fatigue syndrome, the growth hormone levels that are secreted at night, every night while you sleep, you're supposed to have a big surge of growth hormone. We know that in people with chronic fatigue syndrome, those growth hormone levels are cut in half. And that is a hormone that's critical for cellular healing and regeneration. So if you're every night cutting that in half, that's a big, big problem. Another key aspect of what's going on here is autophagy and mitophagy. And these are cellular cleanup processes that involve basically breaking down dysfunctional, worn out cell parts and mitochondria and rebuilding new healthy ones. And that process has to happen at night primarily, and primarily while you sleep, and has to be in a fasted state, something we'll talk more about in a second. We also know that our brain, this is a recent discovery in science, our brain has a lymphatic system called the glymphatic system. This is really a brand new discovery in the last few years, where for decades it was thought the brain didn't have any lymphatic system, and then recently it was discovered actually it does. It's just anatomically a little bit different as far as how it's structured. But that system cleans out all kinds of toxins from our brain every night while we sleep. We also know that melatonin, which is another hormone. Most people know melatonin as like a sleep supplement. Maybe they know it's a hormone and they think of it as a sleep hormone. Well, it turns out melatonin is actually the most potent mitochondrial antioxidant that there is. And it is produced in abundance every night. It's supposed to be produced in abundance every night prior to going to sleep and during the night while you sleep. Well, we know that the modern environment, due to artificial lighting, suppresses our melatonin levels by upwards of 70% every night. So what happens when you're chronically suppressing for years, for decades, this critically important hormone to protecting your mitochondria every night and helping them avoid accumulating lots of damage? Well, you accumulate lots of damage if you're suppressing that hormone. So when our sleep and circadian rhythm are disrupted, these are all the different kinds of effects that we get. We get suppressed autophagy and mitophagy, these cleanup processes in the cell. We get accumulation of toxins in the brain. We get the decrease in melatonin that's leading to the accumulation of damage at the mitochondrial level. And we get widespread disruptions in both neurotransmitters and hormones that impact heavily on our sleep and our cellular regeneration and our mood and our energy levels. So there's many different ways that circadian rhythm ultimately causes fatigue. Now, the goal here is to have an optimal circadian rhythm. You want both the central clock in the brain and the peripheral clocks in the body to be in sync with one another. You want to send the signals that optimize both of them, but you also want them to be synchronized to one another. The central clock in the brain is primarily responsive to the environmental signal. They use in the research, they use a German word called Zeitgeber, which is basically environmental signals that influence the circadian clock. And the central clock is primarily responsive to light inputs, and primarily the blue wavelengths, to some extent the green wavelengths of light. That and if that sounds weird, just think of being outdoors on a sunny day and looking at a blue sky. If you're seeing the color blue, that's blue wavelengths of light entering your eyes. Also, just the sun emits lots of blue. That's part of the overall spectrum. Even though the sun doesn't appear blue, there's lots of blue light in it. Now, those blue and green wavelengths of light, those photons of light, go into our eyes and they hit receptors, and then they feed back through nerves into the suprachiasmatic nucleus of the brain. And that gives your brain the signal it's daytime, the time to be awake, alert, active, energetic. Okay, and the absence of those blue light photons hitting those receptors in your eye and feeding back into the circadian clock tells your brain, okay, it's nighttime. It's the time to wind down, rest, relax, and sleep. Now, the problem is the modern world has completely thrown that on its head, because we now exist in mostly indoor environments during the daytime instead of outdoor. And there's 100 to 1,000-fold difference in the light intensity, as well as differences in the spectrum of light that are influencing that circadian clock. And then in addition, after the sun goes down, where historically our ancestors, for 99.999% of human evolution, didn't have artificial light sources, and they sat around a firelight, which was largely devoid of blue wavelengths of light and doesn't disrupt circadian rhythm. Now we're in indoor environments with lots of artificial light sources, from indoor lighting, computer screens, cell phones, etc., that are emitting lots and lots of blue light that's entering our eyes and giving our brains, our circadian clocks, the daytime signal. Okay. Now, so that's fundamentally what's the short version of what's disrupting the central clock in our brain. At the same time, we have all these peripheral clocks in our body that are not being synchronized to the central clock in our brain. And we know there are a number of things that cause this. Too long of feeding windows, that's the time from your first bite of food to your last bite of food. Too much consumption of food in the nighttime hours, and too much food consumption close to bedtime are probably the biggest ones. So to address this, one of the most important strategies you can take is to address your time, to implement time restricted eating, to address your eating window each day. Now, there was research that was done from a researcher named Sachin Panda, who's a circadian rhythm and sleep researcher. And he had people track with their phones every item of food that they ate for several weeks. And what he found was that people have eating habits that are radically different from what they think they have. So if you ask them, how often they eat and what are the hours that they consume food, it's very different than when you actually track their food. Now, it turns out that over 85% of Americans had a feeding window, an eating window, time from the first bite of food during the morning to the last bite of food at the end of the day. They had a eating window of 13 to 16 hours. Okay, that is chronically disrupting all of these peripheral circadian clocks throughout our body. Okay, because those clocks need to know, just like the central clock, they need to know what is the difference between daytime and nighttime. So that long of an eating window is the equivalent of the modern world sending bright light signals into our eyes, disrupting our circadian clock all day long, 13 to 16 hours. Okay, we're not designed to have light entering our eyes for that long each day, and we're not designed to have food entering our bodies for that long each day. Our body needs a break. Now, it turns out that the optimal feeding window or eating window each day is somewhere between 6 to 10 hours. Now, we know from several studies, lots and lots of animal studies and many human studies as well, that when people implement that change and they condense, even if you don't ask them to change their diet at all you say is just condense the food that you're eating into a 6 to 10 hour window. We know that it decreases oxidative stress. We know that it keeps mitochondria more youthful. We know that it decreases metabolic dysfunction. It increases insulin sensitivity. It decreases markers of chronic inflammation, and it improves sleep quality and energy levels just by making that one shift. So that's a critically important thing. We also know that those processes of cellular cleanup and mitochondrial cleanup and regeneration I mentioned before, autophagy and mitophagy, depend upon an adequate fasting window each night. So if people have a long feeding window each day, 13 to 16 hours, like most people do, you're shortening the length of the fasting window because there's only 24 hours in the day. So the more you condense that fasting window, the more that you are eating away, so to speak, at your body's ability to enter into prolonged and deep states of autophagy and mitophagy. So that's one of the core strategies that I talk about in the Eat for Energy book, as far as how to optimize your circadian rhythm.
You've talked a lot about how to help the circadian rhythm, not only through the light receptors, blue light, and making sure that you, I'm not sure if you would say just reduce or be more mindful about the amount of blue light that we're exposing ourselves to, especially in the evening, because that does affect our growth hormone and melatonin levels. And then also about the nutrition and the part that it plays in autophagy and fasting, or it sounds to me like intermittent fasting, if it's around 16 hours of fasting and then you eating between 6 to 10 hours of eating your meals within that time, so it gives your mitochondria time to clean up, right? So those are good tips on how to help the circadian rhythm part of the energy, and that you, I think, describe a lot more in your book. And so I was wondering also if you can just go in very briefly, about how supplements can play a part in healing the mitochondria. Is it good? Is it only nutrition, or do we need to be able to support our body in a certain way using supplements?
Yeah, great question. So, I mentioned earlier, I've been doing this for a really long time. I've been studying health science for a really long time, since I was a little kid. And over that time, I've had a lot of positions that I was convinced of certain things, and I had certain belief systems and ideologies. I've done every extreme diet you can imagine. And at each point in that journey, I've been convinced that's the one right diet. This is the best diet ever. And, it's keto. Oh, no, it's vegan. It's a meat-based carnivore diet. And no, it's a lectin-free diet. It's paleo, it's Mediterranean, So I've seen a lot of things change over that time. One of the beliefs that I had at some point in that journey was supplements are not necessary, and that you can get everything that you need from your diet. Well, this view it has a grain of truth in it, and I would say it's largely misguided thinking, and just it's not high quality thinking. Here's what I mean by that. In terms of supplying your body's nutrients, the necessary nutrients that it needs to function, the required nutrients, what are called essential nutrients, that have to be acquired in order for the body to function. You could say, well, it's better to make sure that it's better to get those things from your diet. Well, except that the modern diet is largely deficient in many, many of those things. So even when researchers analyze different common meal plans out there, different common diets from South Beach to Mediterranean to this, to that, many vitamin and nutrient deficiencies are extremely common. We also know that the average American, we know that over about 90% of people are deficient in vitamin D and vitamin E. So when we look at deficiencies in other nutrients, so certain other minerals, whether we're talking about magnesium, whether we're talking about vitamin K, vitamin A, vitamin C, things like that, deficiencies also are in B vitamins. Deficiencies are in between 30, 50, 60% of people. So when in terms of each one of those things. So when you do the math on that, you realize that most individuals are probably deficient in at least 3 or 5 or 8 different vitamins and minerals. And this is just talking about essential vitamins and minerals. So we also know when it comes to chronic fatigue, or actually when it comes to just people more broadly, we know that the use of a comprehensive multivitamin and mineral formula is linked with a 6% decrease in all-cause mortality. Okay, and there's very robust evidence to support that. We know that in the context of people with chronic fatigue specifically, just a few months of using a multivitamin and multimineral formula has been shown to increase energy levels by almost 40%. Again, just in the span of about a few months, just by supplying these nutrients that are that most people are commonly deficient in. So I don't see a strong argument against using those compounds. Like there isn't an equally strong array of evidence saying, well, these people experience health benefits by going off their multivitamin and mineral supplement, right? But we do have evidence to say that using those things are linked with decreased rates of diseases, longer lifespan, and more importantly for our context here, higher energy levels in those with chronic fatigue. So I think there's a very strong and compelling argument against the position of avoiding supplements. Now, that is just to discuss essential nutrients. Now, if we start to talk about, well, there's other compounds in certain herbs and in certain other supplements that aren't in this category of essential nutrients. So let's say, as an example, gynostemma, which is an adaptogenic herb that comes from Asia, or rhodiola rosea, called golden root, that comes from, I think, mainly Siberia. These provide compounds that have very clear, profound benefits to human physiology, but aren't essential nutrients. You cannot find them in any other foods. They are uniquely in only those substances. So in other words, they're substances that you cannot replace with just eating a healthy diet. You don't get the compounds in rhodiola rosea by eating romaine lettuce. You get them by only from rhodiola rosea, right? So we have evidence, for example, on acetyl L-carnitine in older adults with chronic fatigue, showing 40 to 50% reductions in levels of mental fatigue and physical fatigue and overall fatigue severity in the span of just a few months of just using that one formula. We know there's another compound called NT factors, which is a phospholipid supplement that basically works to replace damaged phospholipids in mitochondrial membranes. And we have numerous studies in people with all kinds of fatigue from old age, chronic fatigue syndrome, fatigue from obesity, fatigue from Gulf War illness. And we know that using that supplement for just a month or two increases energy levels very reliably in people with chronic fatigue by 30, 40, 50%. Just not making any other change, but taking that one supplement. And again, these are things that you're not going to get in the same level with just eating a healthy diet, no matter how healthy the diet is. In the case of NT factors, unless you're consuming the most phospholipid rich foods on the planet, like let's say salmon roe, you're just not going to get those substances. Do you want to jump in with a question, or do you want me to carry on?
I would say that it's always good to keep in mind that don't just try supplements by yourselves. I would always recommend that you ask your practitioner or someone who understands your body, because I've had patients who actually did not do well on adaptogens because they just jumped into it and they did not know the dosing or the right way to do it. So always, ask your doctor. And if you don't know, you can always consult, whether it's Ari or consult me. But there are people out there that understand what you're going through. So foods are just usually way more safer, but a lot of times I tell my patients, yeah, I can't tell you to eat 60 oranges for you to get the right amount of vitamin C, and so yeah, supplements definitely have a use, and you have to use them correctly. And so I'm glad you're bringing up these really exciting researched types of supplements to be able to help people with chronic fatigue. So yeah, what else is there?
So yeah, a couple other examples. If I can comment on everything you said, I agree with you. I do think that's also generally true of most things, though. So it's also the case that someone could overdo sun exposure, and get sunburned. It's also the case that someone could start an exercise regimen and overdo it radically and cause a huge amount of muscle damage and be terribly sore and or injure themselves. It's always good whenever you implement anything to research it and know what you're doing and have a good understanding of what is the appropriate dosage. How do I do this correctly? I think that rule applies across the board. Even something as innocuous as water. It's if you drink 2 gallons of water in the next 10 minutes, you cause permanent brain damage and maybe put yourself into a coma or die. So it's possible to overdo anything, and even the most healthful things. So yeah, it's definitely across the board. It's important to do things well and to know what you're doing. A couple other ones worth mentioning here. Panax ginseng is another great compound. Lots of evidence to show that it improves mitochondrial function and improves energy levels in those with chronic fatigue. EGCG from tea, from green tea or black tea, is another compound that has widespread beneficial effects on modulating mitochondrial function, improving mitochondrial biogenesis, the creation of more mitochondria from scratch. Astaxanthin is a wonderful compound. That's a carotenoid that comes from algae. This is the pink carotenoid that accumulates up the food chain in other animals. This is why salmon are pink. This is why flamingos are pink. It's from this carotenoid called astaxanthin. And just like it accumulates in salmon and turns their tissues pink, it also bioaccumulates in our bodies, where it has all kinds of beneficial effects. And it has a unique effect on mitochondria because unlike most antioxidants that sort of either function inside or outside the mitochondria, astaxanthin actually has a unique chemical structure that allows it to embed itself across mitochondrial membranes and stabilize mitochondrial membranes and protect them from damage. And if the mechanisms are not impressive enough to you, there are many studies showing that it improves energy levels, it improves sports performance, it increases recovery from exercise, and many other benefits. Also, it acts as an internal sunscreen. It accumulates in your skin and protects your skin from UV damage. PQQ is another one. I think the full name for the substance it's a mouthful. It's something like pyrroloquinone quinine. But PQQ for short, it's one of the most powerful stimulators of mitochondrial biogenesis. Again, that's the creation of more mitochondria from scratch. So those are some of the more important ones that I'll mention here, but all of them have proven benefits in the context of increasing energy levels in the context of people with chronic fatigue.
That's great. Well, thank you for all those pearls. Ari, we are so glad to have you on the Dr. Lam Show, as we have these practical tips in order to help our people out there that are listening on how to help their chronic fatigue with whether it's supplements or lifestyle tips. So any last words for them? Where can listeners find your book?
Yeah, go on Amazon, grab my book. It's called Eat for Energy, and it's going to be out on May 10th. And you're going to learn a whole bunch more than what I covered here. This is really just scratching the surface. The book goes into in depth on circadian rhythm optimization strategies, body composition optimization strategies, blood sugar optimization strategies for anybody who's struggling with either high or low blood sugar or fluctuations. as well as gut health and brain health. And it's got a whole basically an encyclopedia on all the top supplements for boosting mitochondrial health, for boosting sleep, for neurotransmitter optimization, and so much more.
That's awesome. And what are your social media or website?
I don't do much on social media, but my website is theenergyblueprint.com.
Okay. All right. So we're so glad to have you on the Dr. Lam Show. If you've liked it, make sure you subscribe and share it with those who you think really need to hear this. We hope you stay tuned for our next episode. We'll see you next time.